everybody, welcome to this video. In this video we're going to have a quick review of random number generation in C. So on the screen here you can see I've got some code displaying, and let's start right at the top with our includes. So when you want to generate random values, make sure that you include these two libraries, s3lib and time.h. You're going to need those two libraries for the random number generation, as I'll describe it down below. So in here I've written all the code in the main function again. So there's the beginning of the main function. I have an integer array size 100. I have a value integer variable called value, and I have an integer variable I, which is just basically going to be a counter variable for myself. Then the very first thing, if you want to generate random numbers, then you have to use the srand function from the s3lib library. That's the standard library. So srand basically establishes or sets the seed value. And if I send to it as an argument, so there's my argument that I'm sending to srand, time null. Time null is basically the current computer clock. So I'm setting my seed value to whatever the current computer clock value is. So that's just to make the seed value different if you run your program one after each other, not too quickly, but if you run it after each other, most times it will be a different seed value, which in turn will create a different series of pseudo random numbers. Okay, so it's very important to set your seed value, and we only do this once. Just do it right at the beginning of your code, your program, before you start with the remainder of your code. Put the srand right there and then, and be done with it. You don't have to do that again. Then let's go and see how do we generate some random values. So in this first for loop here, we're demonstrating to you how to generate, and then of course we're printing it to the screen so we can see it on the console as well. How to generate some random values. So the loop runs 100 times because I basically want to generate 100 random values. So I'm generating the random values on this line 20, and I'm storing it immediately to my value variable, that variable that I've declared up there. So this here is the part of the statement that generates random values. So basically you call the rand function. Rand is also in s3lib. By the way, this time null is the one that comes from, or that resides in time.h. Okay, so rand is a random function in your standard library, and will basically turn a random value, a pseudo random value, but it will be a very large, in a very large range, up to tens of thousands. I think in the early 30,000s. So it's a very large value, and most, if not all of the times when you generate random values, you want those values to be in a specific range. So in fact here I said the range must be 0 to 10. So how do we now convert this very large range of random values to a specific range? We use the mathematical operator of remainder. So there's the percentage symbol, which is the remainder operator in C, and I'm saying rand mod or remainder 11. So that means I'm finding whatever value rand returns, that large random value, and I'm finding what is the remainder if you divide by 11, the whole number remainder. So that means the possible values, the possible remainder values that can be determined is 0 to 10. So this statement here will create for me random values in the range of 0 to 10. All right. Now we can go and shift it. So it's 0 to 10. Let's say we wanted to make it 1 to 11. I just simply add 1. Then it will be from 1 to 11, because we'll add 1 to every one of those values no matter where they are in that range. Or let's say I wanted to make it minus 1 to 9. Then I can shift it negatively by subtracting with 1. All right. The second thing I'm doing in this statement is I'm writing the value to my variable value. The reason I'm doing that is once the value has been generated, I want to keep track of this value. I want to store it in memory, so I have that specific value that I can access at any point in time when I want to. If you just generate a random value and you later on run this same statement, you're going to get a different value, and that's not always what we would like. So in this case, we're generating a random value and storing it to memory, and then we are printing the value from memory. Okay, so really this is not actually necessary. This is a little bit of a long road that we're taking. It's just for illustration purposes, so that you can see how can you generate a random value and immediately write it into a variable so it's stored in your computer memory. And then on the next line we just simply print that value that was stored to memory. Then the loop will run again. We will generate a new value. That new value will override the previous value in the variable, and we will print that value from the variable. And that will keep on happening over and over and over. We could have just written this entire line, this entire for loop could have just had a printf, and then instead of value we just could have generated a random number right there. So that statement could have been right there in the printf. Okay, I'm going to comment that out for now. But we can replace both these lines with that single line. The difference is here we're generating the value, printing it to the screen, and it's never stored to memory. So if we need to access it again before it's overwritten, at least, then we cannot do it this time. So that's the only difference here, but we will still generate random values and it will be printed to the screen according to what we describe in the commentary just before the for loop. Okay, so we'll see that in action in a short while. And then this second for loop, now I'm generating random values again, but this time I'm storing it not to a variable or not just simply printing it to the screen. I'm storing it to the array, into an array. Now the array I have here is a size 100 array. I'm running the loop 100 times and I'm generating a random value and writing it to each and every position in the array. So I'm using I as my index. I ranges from 0 to 99, meaning it will span the entire array elements. So I will write to each and every one of them. And it should be random values. I mean, it will be random values, but it should be different values depending on the range. So we have 100 that we'll be generating because the loop will run 100 times. But the range is from 0 to 10. I expect to see some duplicates, but not too many, and there should be a pretty nice and even distribution. And after I've generated and stored a value to the array, I'm immediately printing the array back to the screen. This did not have to happen inside this loop. Since we have stored now all the values, the generated values, since we stored all of them to computer memory in an array, we now can go and read or recall these values at any point in time, later in our program. So it doesn't have to happen immediately as you're generating. You don't have to immediately display them. We could have had another loop here, and I'm going to create a loop and put it in commentary just so you can see what I mean. So we could have had a second loop, and the second loop is just there. The second loop is just there to read from the array. I didn't have to go and read from the array immediately. However, I'm just trying to save space here because we want to print it to the screen. But should you need to access or display the array at a later point in time, then that's what you'll do. Be careful though, and please note this. I've seen a lot of students make this mistake. Do not generate values here again, guys. You generate the value once, you store it to memory. Once you've stored it to memory, it's there. You don't have to generate it again. In fact, you should not generate it again, because then your values are always going to be changing. Okay, you want to generate it once, store it to memory, and then just simply recall it from memory whenever you need it. If it should change at that point, yes, then that's another matter. But if you just want to generate once, have a set of random values, then don't go and generate again and again and again. Then you just have this once in your code. I have it twice because here I'm demonstrating to you to write to a variable. But if I didn't want to generate and store to a variable, I won't even have any of this code up here. Then I'll just have this, generate, store. That's it. Then these values are now safe and secure in my computer memory. So as long as this program is running, I have access to those values. Alright, so let's quickly build and run this code. So there's a whole lot of values here on the screen. Basically, this first block of values is the first generated values that I write to the variable and then read it, and then it overrides the value. This 8 is the second value generated, will override the 10 in the variable, but then we display it again with one tab space up and up and up. So you get this tabular layout of the array, or actually not the array, of the generated random values. Because up here we're just working with a variable. But as you can see, there's a lot of values. If you count them, you'll see it's 100 values, and they're all in the range from 0 to 10. Okay, and that's as a result of the code up here. This code here. Of course, you had to have that srand before you start generating any random values. So this block of code is generated by this block of output is generated by this code. Then we have a second block here of output. And this second block is generated by this code here. And that means these values has been stored to the computer memory, all of them. Each and every one of them. Not just the last one. Up here, just the last one was stored to memory because before that there was another value in that variable. But down here, all of these values have been stored to an array that can store 100 values. So all of these values are available in the computer memory. Let me just quickly show to you the difference here. If I should comment out these two lines and bring back in that line, and if I should comment out the printf and take out those commentary lines, close this window, build it, run it again, you can see I have the same kind of output. Remember, of course, because it's random values, you won't see the same values unless you read that array a second time. Now maybe I should show that quickly in this review. So there I've generated values and stored it to my array. Here I'm displaying my array, I'm reading from my array. Now I'm just going to do this. I'm going to copy and paste it. Here I'm going to say printf. Let me just sort that out. Printf array values. Alright. So there I'm saying array values. So these will be the values the first time we review the array, and then I'm going to print it out a second time. Same array, but later on in my code. So I should see the same values twice. Let me just create a little bit of space between those two blocks. So let me build. Alright, so here you can see array values. The first time we generate it, we store it to the array. Look at the values, 0, 4, 3, 8. It ends with 1, 3. Then I'm printing out the array again, 0, 4, 3, 8, 1 and 3. You can see these two blocks are identical. Why? Because when I generated these values the first time, I stored it to my array in memory. And then I printed it. So that there I'm generating, storing to my array. Then I'm just simply reading from my array. That's what you see here. And then I'm reading from my array a second time. That's what you see here. So what I could do is I could take this out again as a further example and bring that one back in. So in this loop now I'm generating and displaying as I'm going, okay, in a tabular format, but it's stored to memory. Then later on my code, now I'm just reading from the array, and you can see here I'm not generating anything in this for loop here. I'm just printing, just printf. Now let's take a look at the output from this. Okay, look at the values here. That's the one with the variable. So we're jumping over that now. These values were generated and written to the array 43838. It ends with 02. And then I'm reading the values from the array. I'm not generating again. I'm just reading the value from the array. 43838. 02. You can see beginning and ends exactly the same. In fact, if you visually just quickly compare, you'll see it's identical. And that's because here I'm printing the values that were generated and stored, of course. I'm printing the values from memory. And here I'm just printing the values from memory. I don't have to generate it again. Alright, I hope that clarifies a few things for you guys. I've seen this mistake too many times. Don't go and regenerate this. Don't go and put this line down here again. It's not what you should do, because we don't want to generate a new 100 values. We want to just generate it once. I cannot say that enough times. Alright, so here's your exercise, a short exercise. Using this code basically, I'm showing you here. Generate, store to an array and display 20 random numbers that's in the range -5 to 5. So I want to see 20 random numbers on the screen, -5 to 5. And they should all be stored to an array, a single array. Okay. Then find and display the minimum, maximum, average, amount of negatives, amount of zeros, and amount of positive values. So here, you're not generating anything again. The generation happened up there. Here, you're just simply going to read your array, and you're going to go and determine how many negative values are there, how many zeros, how many positives, what is the absolute minimum value, what is the absolute maximum, and what is the average out of all of these values. Alright, I haven't declared any variables in this exercise. You have to go and declare the variables. Just make sure you declare each and every variable with a specific purpose. Don't create more variables than necessary. And if you need, obviously, also an array, you have to store to an array, so you need to at least have an array. And that's it for this one. Thank you.